Welcome everyone to the NPTEL online certification course for problem solving and doubt clarification. This is the course for water and wastewater treatment, and we are in week 6 now. As you all know, the course instructor is Dr. Bhanu Prakash, and I am one of the teaching assistant. My name is Akash Saha, and I am a PMRF scholar at the Department of Civil Engineering at IIT Madras, where I am pursuing my PhD in environmental engineering. Okay, so uh, okay, yeah. So if we see the contents of week 6, so we started with the discussion of phosphorus removal, and we majorly focused on the biological phosphorus removal using the phosphorus accumulating bacteria or organisms, and we also discussed about the chemical precipitation technique for the phosphorus removal. Then we moved on to see and discuss about the secondary clarifiers and the attached growth system. Okay, so we discussed each of the component of the secondary clarifier, what are the different types of settling, what are the design criteria, and then we started discussing about the attached growth system, where we have seen like uh, different techniques like the trickling filters, the rotary biological contactors, and the moving bed biofilm reactor, okay, or the MBBR. And then we talked about disinfection, where first we talked about the chemical disinfection kinetics, how to design it in plug flow criteria, and then what are the different disinfection methods. Okay, so majorly we started off with chlorination. What are the different redox reactions? How chlorine gas can be used? What are the uses of hypochlorite or chloramines? And at the end, we discussed about the disinfection byproducts, how they are formed, what are different types of the DBPs, and what do we mean by the chlorination breakthrough curve. Okay, we talked about the breakpoint chlorination, and then at last we discussed about the ozonation and the UV disinfection. So a lot of things were there in the weeks in this week's content. So one by one, we will see how to solve the MCQ problems, and then we will have some numericals also. Okay. I hope you are able to follow the assignments and you are submitting them on time. Okay. And if in between the week also, if you have any doubts in solving your assignment problems, you please reach out to me through my email address, which I will anyway present at the end of the session. Okay. So this is the first problem. It says that select the correct option about phosphorus removal. So here we are talking about the biological phosphorus removal. So which of the options are correct? So first option, it is saying that phosphate consumed by bacteria in aerobic zone. Then bacteria forms PHBs by fermentation of byproducts in anaerobic zone. Then polyphosphates break down and orthophosphates are released in the anaerobic zone. And then all of them. So you have to tell me which of them are the correct options. Okay. So, Mohan, can you tell me which of the, like, we have three processes written in this question, right? So, which of them is the first process? Like, what happens first? Can you tell me?
Sir, in aerobic zone, uh, phosphorus is
Yes. See,
uh,
we have two zones. One is the anaerobic zone and one is the aerobic zone. So,
yes,
first,
yes.
the process happens in anaerobic or aerobic? First, you tell me.
Process in aerobic.
Is it aerobic or anaerobic? Just think about it. See, you might
Uh,
remember first this polyhydroxybutirates or polyhydroxyalkyl units are formed, PHB or PHA. Okay, so this
okay.
formation happens in anaerobic zone or aerobic zone.
First formation in anaerobic and then
Yeah,
aerobic is received slowly, slowly.
yeah. So that means the first zone would be anaerobic. Okay, so what
Yes, yes.
happens is the first in the anaerobic zone. So I will just write it so that you get an idea. So this is a new week. We are in week 6 now. Right? So, okay. So question number 1. So first, what will happen? The wastewater, whatever is there, it will first enter the anaerobic zone.
Yes, sir.
Okay. So here what will happen? Here the PAO, what is known as the phosphate accumulating organisms. Okay.
Organic.
They will consume what? They will consume VFAs. VFAs are nothing but volatile fatty acids. These are some fermentation byproducts. Okay. So these can be some acetate, okay, or maybe propionate. Okay, so these things will be formed only in anaerobic zone. Okay, so this PAO will consume these VFAs, okay, and then store them as
B.
the PHA or
B.
PHB, whatever. Okay,
Yes,
so
yes.
this they will store. And for this, what is required? For this, the most important thing is required is energy. Okay, so hello, am I audible? Okay, sorry, actually, there is some power connection problem. Okay, so just hold on for a minute. Yeah, I think it's fine now. So we were discussing about the phosphorus uptake. Okay, so what happens in the anaerobic zone? So in the anaerobic zone, what will happen? This phosphorus accumulating bacteria, they will consume these VFAs. So these VFAs are nothing but some byproducts which are formed in the anaerobic zone, and these can be in the form of acetate or propionate. Okay, so these are the different kind of VFAs, and uh, to store them as PHA or PHV, we need some energy, right? So to store them, we need some energy. So for this, so for this to generate energy, this PAO, this PAO will release the orthophosphate, okay, in liquid. In the liquid phase. Liquid phase means in the system. Whatever system is there in the wastewater, it will release. So always remember in the anaerobic zone, the pHs are getting formed, and to form these pHs, these phosphorus accumulating bacteria will release some orthophosphate from their system. Okay, so this is the first step, anaerobic zone. Then what happens in the second zone? Now this wastewater first anaerobic, and then from there it will go to the aerobic zone. Right? It will go to the aerobic zone. So what will happen in this aerobic zone? Aerobic zone. In this aerobic zone, this PL, okay, will use the formed PHA as energy, and they will uptake phosphorus. They will uptake phosphorus. So again, what is happening now in the aerobic zone? Whatever phosphorus or phosphate is there in the system, the bacteria is again taking up in their system or in their cell. So for that now the energy they are using is in the form of PHA. Okay. So this uptake or this taking back of phosphorus is known as luxury uptake. Is known as luxury uptake. Why this is called as luxury uptake? Because how much like whatever phosphorus is required for them to survive, they will take more than that. Okay, they will take more than that. That's why it is called as luxury uptake. So in that way, what is happening is net phosphorus is getting removed from the system. Net phosphorus is getting removed because here also some phosphorus is getting out from the system, right? Is getting out in the liquid. Okay, but again, this phosphorus is being taken up by the bacteria. So if we see the net amount of phosphorus that is being taken up, it is more than what is released. So that's why it is known as luxury uptake. Okay, is there any problem?
No, sir.
So this is what happens in any biological phosphorus system. So here all the options are correct because the bacteria forms these PHDs from the fermentation byproducts. Then polyphosphates break down and orthophosphates are released in the anaerobic zone, and also the phosphate is consumed by the bacteria in anaerobic zone. So all of them are. Now next, which of the following pair is not correctly matched? So we have trickling filter with attached growth system, activated stress process with suspended growth system, MBBR with less surface area to grow bacteria, or secondary disinfection for inactivation of pathogens. So which of them do you think is not correctly matched?
Is it option C, sir?
So what will be the correct pairing? Like what would be the correct answer? If MBBR is not does not necessarily relate to less surface area, then what is the correct way of representing? So why are we going for MBBR when we have an ESD system already? What is the need of an MBBR? First of all, what is the full form of MBBR? Anyone? What is the full form of MBBR?
Sir, moving bed biofilm reactions.
Yeah, so moving bed biofilm reactor. So what is the advantage of having a moving bed biofilm reactor? What is the advantage?
It
Less area.
reduces impurities.
Sorry? No. See, moving bed biofilm reactor means what is happening. Suppose this is my aeration chamber. Okay, some wastewater is coming into the system. So mostly what happens is this bacteria will be freely suspended in the system. Okay, and we are providing the oxygen to them. We are providing the oxygen, and the biodegradation is happening. Okay, and then the effluent is also coming to the secondary clarifier, and from here we are again recycling it. So this is what is happening in a general age, right? Now in MBBR what happens is instead of this bacteria to fully move, we provide some kind of carriers, some kind of plastic or some aerated blocks, some kind of carriers. So what will happen is these carriers will freely move, and on that the bacteria will attach. On that the bacteria will attach. So now the surface area of bacterial attachment is increasing because we are providing this plastic carriers or whatever media in the system. So in this way, the surface area is increasing and less number of bacterial mass are going out from the system. Okay, so recycling is also not required in the system. So the system efficiency will increase. So that's what happens in an MBBR. So this is a moving bed biofilm reactor. The bed or the bacterial biomass is moving in this reactor, right? Okay. So the correct answer is MBBR increases the surface area rather than decreasing the surface area. Next, which of the following form of chlorine disinfectant requires highest contact time to inactivate 99% of the bacteria? Is it NH4Cl, OCl minus, or HOCl? Which requires highest contact? So highest contact time means which is the least efficient. These are the efficiency, the more contact time. We are saying highest contact time means which one of them is least efficient or have the least disinfection. Any idea? So NH4Cl or it is a kind of chlorine, so or ammonium chloride. So these will have the least disinfection power. Why? Because this HOCl, okay, HOCl is nothing but hydrochlorous acid. Okay, hydrochlorous acid, and it is a very strong disinfectant because most of the time this HOCl is a neutral molecule. Okay, so it will be easily penetrating through the microbial cells. So for disinfection, what generally happens is this disinfecting chemicals they will penetrate the cell wall of the microorganisms and they will die. Okay, they will disrupt their proteins, enzyme, or nucleic acid, whatever is present in the bacteria cells, they will disrupt it, and uh, then the disinfection will happen. Okay, so why HOCl is a very strong disinfectant because it is a neutral molecule, so the resistivity will be lesser. Whereas HOCl minus is a kind of anion, it is having a negatively charged, so some resistance will be there to enter into the bacterial cell wall. Okay, so but it is still more powerful than the chloramines because these chloramines are not at all an oxidizer and they will take more and more time to penetrate through the cell wall and cause the disruption. Okay, So that's why chloramine will have the least disinfection power, and hence it will require the highest contact time. Okay, right? I hope it is clear. So the answer is A, NH4Cl. Okay, moving forward. Identify the following wrong statements. Okay, so here statements are here. You have to find out which one of them is incorrect or wrong. First one says in disk filtration, aeration is controlled by rotation of disk. Then Na2SO3 removes free chlorine from the treated wastewater. Then disinfection byproducts also form in drinking water. Then presence of high concentration of H2S and ferrous ions will increase the residual chlorine in treated wastewater. So we have four statements talking about different things. So just go through it one by one and tell me which one of them is incorrect. D. Any other incorrect option? Can you find out? Is there any other incorrect option?
A, sir. A.
A. Why do you think A is incorrect? So suppose we are there are some disk and it is rotating. If the rotation power is more, don't you think the aeration will be much better? Okay, so aeration can be controlled by the rotation of disk. So that is true. That is not a wrong statement. What about the second one? Na2SO4 removes free chlorine from the treated wastewater. Is it true?
Yes, sir. Is it true?
It is
Sodium
true.
sulfide.
Yeah. So that process is known as dechlorination. Okay, dechlorination we
Yes,
called it. So they can be used to remove the free chlorine from the treated water. Now come to the third statement. Disinfection byproducts also form in drinking water. Is it true or false?
sir. It is also true.
It is also true. Now, here some ambiguity will come. Okay, so if the drinking water is free from any kind of bromide, chloride, or any all this or organic matter, then how will these disinfection byproducts will be formed? Okay, so there is always a debate. Okay, there can be a debate. So disinfection byproducts, if some kind of organic matter, all these chloride things are there, then maybe it can form. But most of the and if it is completely free from all kind of organic matter and all, then this will not form. So okay, so some ambiguity can be there. So though in the correct answer, C is also marked as wrong statement, but that can be also true sometimes. Okay. And D is definitely wrong because if this H2S like hydrogen sulfide or ferrous ions will be there, it will consume the chlorine. Okay, it will consume the chlorine, hence the residual chlorine will be lesser. It will not increase the residual chlorine. So D option is also wrong, right? So this is another question. Uh, okay. Mm, okay. Okay, then we will move forward. Next question is UV disinfection process produces hydroxyl radicals in treated wastewater. Is it true or false? UV disinfection process produces hydroxyl radicals in treated wastewater. It is true. So, so can someone tell me what is this process called through which the UV light produces radicals? Any idea?
Sir, in UV detection process, directly damaging the nucleic acid, water of nucleic acid directly damaged by
Yes,
this
yes, yes, yes. No,
radiations.
Yeah. Whatever you have said is correct. It will directly attack the nucleic acid of the bacteria. And so for that, we need some radicals. And these radicals are produced by the UV light through a process called photodissociation or photolysis. Okay. It is known as photodissociation or photolysis, where these UV photons will break the chemical bonds in molecules, creating a highly reactive radical. Okay. There can be OH radical or sulfate radical. Okay, so there can be nitrate radical. Different types of radicals can be there. So then this will disrupt the nucleic acid. Okay, so it is known as photolysis or photodissociation. And there are many processes through which it happens. Okay, I'm not going into this, but I'm just telling you. It can be called as homolytic bond cleavage or excitation and reactions or UV induced ionization. So just I'm telling you, no need to remember ourselves. Just remember that with the help of photolysis, this UV rays will form the radicals. Next question. Okay, so it's a small numerical. It says that the treated wastewater discharge 1000 meter cube per day, entering the disinfection unit, and number of organism remains after contact time T is NT equal to N naught into e to the power minus KT. So the equation is directly given. Now find out the volume of disinfection unit required to achieve 98% disinfection. Okay, here K is the disinfection rate constant equal to 0.145 per minute. So you have to find out the volume of the disinfection unit, and the discharge is given, and the equation through which disinfection is happening is also given, and K value is also given. So for 98% efficiency, you have to find out the volume. Please try it out. I'll wait for some time and then we can discuss. Please, if you are attending the class, always have a pen, paper, and a calculator. So here we will discuss some numericals. You can try it out. I'll wait for some time, and if you're not able to do it, then I will solve it. And we will solve similar problems. So even if the first time, if you're not able to do it, maybe in the next question, you can try it out. Okay. So most of the time, I have repeated questions on the same logic. Okay. Anyone is trying, or shall I go on and solve it? 18.6. Yeah, you are approximately correct. Yeah, it is around that. Okay, very well. Okay, so for others, I will try to solve it. This is very easy, direct question. So question number 6. So the equation is given. Okay, equation is given, that is NT is nothing but N naught into e to the power minus KT. This is given, and disinfection efficiency. Okay, efficiency. Yeah, that is correct. 18.7 is the right answer. So disinfection efficiency percentage, how we will calculate? So whatever was present, okay, minus the final divided by the initial into 100. Okay, so we need 98% efficiency. So it will be 0.98 equal to n naught minus, instead of nt we will write again n naught e to the power minus kt, okay, divided by n naught into 100. Is screen is not visible for everyone?
No,
It
sir, it
is
is
with
visible, sir.
It is visible. Okay, if it is not visible for you, okay, okay. So again, 0.98 will be equal to n naught minus n naught e to the power. K value is also given. K value is 0.145 into t by n naught into 100. So if you take n naught common, it will be cancelled. So ultimately, we will have the equation in terms of t. So t you will be getting at 26.97 minutes. Okay, so here I think k is given in minutes only, right? So anyway, the answer in minutes will be 26.97. Now for the volume, what you have to do? So volume of disinfection unit will be equal to the discharge into time. So discharge is 1000 meter cube per day into 26.9. I will write it in minutes and convert into days, and then you will get the final answer as 18.73 meter cube. Okay, you have to convert these days to minutes or whatever you feel like, minutes into days, and then you can find out. So the correct answer will be 18.73. Right? We'll move forward. Yeah. So here the answer is also given. Next. So now you have to say, you have to choose the correct option by using the chlorination graph shown below. So we have a graph between the dosage of chlorine in milligram per liter versus the residual chlorine in milligram per liter. Okay. So this is nothing but that breakpoint chlorination curve, right? So four options are given. You have to tell me which of them is correct. So you have to look into the graph and calculate what is the breakpoint chlorine dose, what is the free residual chlorine, what is the combined residual chlorine, and what is the total residual chlorine. And if all of them are correct, then option E will be correct. So tell me which of the options are correct. So here, what will be the breakpoint chlorine dose? What is
1.5.
1.5? So that means option A is correct. Then what about the free residual chlorine? What is the free residual chlorine? Can you find out?
Is it 3 mg per liter?
No, it's not 3. Free residual. You have to just see what is the free residual. So, okay, before that, what is the total residual chlorine? Okay, so what is the total residual chlorine? Just see in the y-axis.
2 mg per liter, sir.
2 mg per liter, yes. So 2 mg per liter is the total residual chlorine. You can see in the y-axis, whatever is the residual chlorine at the end of the chlorine dose, okay, at the end of the chlorine dose of 3 milligram per liter. So we have 2 milligram per liter of residual chlorine. So that will be the total chlorine. So now among the total residual chlorine, how much is the combined residual chlorine? So now we can divide this total residual chlorine into two parts. One is the combined residual chlorine and one is the free residual chlorine. So what is the combined part and what is the free part out of the 2 milligram per liter? Just see here, I will just draw it once again. So this is the chlorine dose, okay, and this is the residual chlorine, right? So the graph is going somewhat like this, then it came down, and then again it went up to here. Okay, something like this. The graph is something like this. So this is 1.5, this is 3, this is zero point 0.5, this is 2, right? These are the values given. Now, whenever you are asked what is the breakpoint chlorine dose, that means at what dose of chlorine, okay, all the chloramines are degraded. So this is my breakpoint chlorine dose. So whatever is on the x-axis, that will be my breakpoint chlorine dose, BPCD. Okay, so 1.5 is my breakpoint chlorine dose. Now, I talked about total residual chlorine. So this axis gives the residual chlorine, y-axis. So at the end of the chlorine rows, whatever is remaining, so this much is remaining as chlorine. So this is my total residual chlorine. So this is nothing but 2 milligram per liter. Okay, so this 2 milligram per liter. Okay, now out of this total residual chlorine, this can be one part and this can be other part. We have two part. Okay, okay, so this part up to the breakpoint part, this is known as combined. This is known as combined residual chlorine, and this other part after the breakpoint chlorination is known as the free residual chlorine. Free RC, free residual chlorine. Is it clear? So my combined residual chlorine will be how much? It will be 0.5 milligram per liter, and my free residual chlorine will be 2 minus 0.5, that is 1.5 milligram per liter. Is it clear? Is anyone is having any doubt here? Do I have to repeat it?
No, sir, it's clear.
It's clear, right? Okay, others also, you please try to respond. If you are not able to understand, let me know. Okay, so here you see the correct options are that breakpoint chlorine dose is 1.5 and combined residual chlorine is 0.5 milligram per liter. Right? Next question. Select the following advantages of ozone treatment. Okay, we are talking about ozone treatment. So is there no harmful disinfection byproducts, or it improves the taste and odor? It is cheaper than chlorination. Does it require less contact time, or the more disinfecting residual power is there for ozone treatment? So you have to find out the advantages of ozone treatment.
Option A, sir.
Option A, no harmful disinfection products. Okay. What else?
And I guess option D.
Option B, okay, it improves the taste and odor. That is also true. Any other?
Can it be D also, sir?
D, yes, it can be D also because it is a much more efficient treatment system. So the contact time requirement will be less. Okay, so efficiency is indirectly proportional to the contact time. So definitely it will require less. Okay, so A, B, and D will be correct. And what about more disinfecting residual power? Will it not give more disinfecting residual power? What do you think?
No residual power.
Why is it? Why it is? Why there is no residual power for
Due to less contact time.
less contact time? Okay, what is contact time? No, contact time is less. Okay, but what is the actual reason? So always remember this UV ozone here, the disinfection is depending on the formation of that discussed. That these processes perform and these particles have a very short duration. So instantly they will effectively act on the pipe. So the efficiency is very high for that particular period of time. But once the UV and ozone is switched off, there will be no disinfection because the lifetime of this reticle. So that is the main. Whereas chlorine and all, it will be there in the form of chloramines. So mostly hypochlorous or OCl, all these things will add it instantly, but it will form some chloramines, and these chloramines will have very slow disinfection power. So for a long time, they will provide some disinfection power.
No doubts.
Next, which of the following is not an advantage of biological phosphorus removal over chemical precipitation method? So we have discussed two types, biological and chemical. So what is not an advantage? Low chemical consumption, low sludge production, high phosphorus removal efficiency, high chemical.
सर क्वेश्चन को एक बार और समझाइए सर.
See, for phosphorus removal, we have two problems. One is biological and one is chemical precipitation. So now from the options, we have to tell which of them is not an advantage of biological phosphorus. Not
Is it option C, sir?
a high phosphorus removal efficiency. Anything else? What do you think?
No, sir. I didn't understand the question properly.
No, no, no. I am saying just think about it. Just we will discuss one by one. Okay. Low chemical consumption. Where low chemical consumption will be there? Biological system or chemical system?
Biological.
Biological. Okay. So that means this is an advantage, right? This is an advantage of biological phosphorus system, right? So here I have to identify which one is not an advantage. Okay. So A won't be an answer. A won't be an answer because it's an advantage of biological system. Then low sludge production, which will have low sludge, biological or chemical?
I guess biological will have less.
Biological will have less. So this is also an advantage, but this is not my answer because we have to mark which is not an advantage. Then
Oh,
high phosphorus removal, again biological as high. So this is again an advantage, but this is not my answer. But now high chemical consumption. High chemical consumption means for chemical. So this is not an advantage of biological. So the correct answer would be high. I know this the way of questioning is a bit tricky. So just go through the options one by one and see which is not an advantage. Advantages we know. So apart from the advantages, we have to answer. So here the correct answer would be only high chemical consumption. Is it fine?
yes, sir.
Others will get advantage. Mohan, is it fine for you now? So now the steps for breakpoint chlorination are given below. So you have to find out the correct sequence. Okay, so destructions of chloramine and chloroorganic compounds, formation of chloroorganic compounds and chloramines, destruction of chlorine by readily reducing compounds, and then formation of free chlorine. So we have different steps of this breakpoint chlorination. So you have to arrange in sequence. Option A, I don't think so it's the right answer. You please try again.
Option B, sir.
Option B. So what happens is first the destruction of chlorine by readily reducing compounds will happen. Okay, whatever compounds which are readily reducing, so they will do the destruction of the chlorine. Then what will happen? Formation of chloroorganic. So I will quickly show you the graph. Okay, yeah, yeah. So the graph is visible. So you can see. So as we go on adding the chlorine, okay, as a disinfection, so immediately the destruction of chlorine by reducing compounds will happen. Okay, till then we have not added any chlorine. So like little bit of chlorine has been added. There is no residual. That's what I'm saying. There is no residual. Only the destruction of chlorine by readily reducing compounds will happen. Then the formation of chloroorganic compounds or we say chloramines will happen. Okay. So when this formation is happening, slowly some part of residual chlorine will be rising. Okay. Then again the destruction of these chloramines will happen. So while this destruction will happen, some part of residual chlorine will be consumed. That's why it is from C to D, it is again going down. Okay, from C to D, it is again. So once the destruction of all chloramines happen, there will be some residual chlorine. Okay, that part is known as the chlorination. So here, what is the breakpoint chlorination dose? Can someone tell me? What is the dose of the breakpoint chlorination?
0.7.
0.7. Okay. And what is the residual combined residual? What is the combined residual?
1.1.
Point one. Point one is the combined residual. So after this point, how much ever chlorine we will add, okay, that, that they will be remaining as the residual. So that's why it's known as free residual. And we can see the 45 degree. So that's why that line is 45 degrees. So whatever you add, that will be remaining as before. So you can see. So now the total residual is somewhat around, I think, 0.5. Okay. So if you just extend it, so somewhat around 0.5, out of which 0.1 is combined residual and the free residual will be 0.4. So like that it is. Okay. So I hope now it is clear the breakpoint chlorination curve and everything. We'll move forward. The mechanism of UV disinfection is that it disinfects by directly damaging the nucleic acid of the pathogen. Just
True, true.
so it. What is the main purpose of using chloramines in water treatment? Is it to remove iron and manganese, to provide a longer lasting residual disinfectant, to remove phosphorus, to remove sulfur, to remove bacteria? What is the purpose of chloramine in water? So actually, he is indirectly correct. He is indirectly correct. But the main purpose of chloramines is to just provide a longer lasting residual disinfectant. Okay, ultimately I know it will remove the bacteria, but the majority of bacteria and viruses removal happens by the chlorination or by the HOC. Okay, majority will happen. Now, in case we might find that there is some future problems of contamination. Okay, so that time this residual disinfectant will be used, which is nothing but the chlorine. So the main purpose is to provide a longer lasting residual disinfection for future contamination. Not that point like while disinfection we are doing but as a future. Okay, so we will be the most happy. But yeah, you can say that he is also correct to some extent because ultimately they are. But if you are asked to answer only a single option, then D is the right answer.
Sir, excuse me. Chlorine and chloramines, could you please any unique difference, major difference between them?
Fluorine and chloramine. Fluorine, based on the pH, this fluorine, when we are putting into the wastewater system, either it will form the hydrochlorous acid, HFO, or OCl. Now, these are instant disinfectant. They will act instantly in the disinfection zone. Okay, but again, we saw the treatment precondition, right? There will be some formation of NH4Cl, NH3Cl2, like that some many bioproducts will be formed. And this will give, and this will be present for a longer period of time. Okay, and
Sir,
ultimately it will,
chlorine disinfection more effectively in low pH or high pH?
yeah, it will be more effective in the pH around 4 to 5. Okay, because in this pH, it will be in the form of HOCl. So HOCl or hydrochlorous acid is the highest, like is the most strongest oxidizer. Okay, so that's why in this 4 to 5 or 6, I think, so at that time it will be the most effective. After that, it is in the form of OCl minus. So that time it is effective but lesser effective than the HOCl. And chloramine is the least effective. So that's how it is. Next is select the correct options regarding advantages of treating filter. A treating filter can withstand shock loadings. Nitrogen removal efficiency is very high. There is no order or file usage and simpler operation.
Option D, sir.
Should be
D.
C or D. I don't think both of them are correct because see, nitrogen removal will not be there in trickling filter, or even if it's there, it will be low. Okay, simpler operation you can say, but yeah, simpler operation will be right. And the major thing of trickling filter is the withstanding of shock loadings. Okay, it will be because it will be able to take more and more organic loading. Okay, the capacity to treat the organics is very high because of the formation of a biofilm over the filters. So it can withstand shock loadings, but the nitrogen removal will be very less or negligible. And due to the attachment of biomass over the filters, there is a possibility that flies will be around. Okay, so there will be a very high order and fly nuisance will be there. And yeah, simpler operation definitely because just you have to spray wastewater from the top and then it will simply pass through the filters. But again, the clogging issue may be there if it is not properly managed. So in between, you have to remove the cloggings. So for that, that is a critical part in the operation. Otherwise, it's a simple operation. Okay, move forward. So what is the correct sequence of formation of following compounds during chlorination of water in which ammonia is present? Okay. So when ammonia is present, there will be form of various byproducts during chlorination. So you have to find out the order. What is the correct order? So yes, we will just see the order. So first, when we mix the chlorine with the water, it will form the HOCl. And if ammonia is present, at first NH2Cl. Then again it will react with HOCl. Then NHCl2 will be formed. Then again they have to react with HOCl and then NCl. So this is the NH2Cl, NHCl2, and NCl. Which of the following is not an attached growth process? Filter, NDBR, SBR, RDC, ESP. I hope you know the full form of these. Which of them is not an attached growth process?
SBR and ASP.
SBR and ALP. Yeah. So NDBR is nothing but moving bed balancing reactors. So I told you filters are there, like moving filters, so that the bacteria attaches. And RBC is protected biological contactors. So there also some attachment is there. The contactors are moving in circular motion. Whereas SBR is sequential batch reactor, which is nothing but a modified form of ESP, okay, where everything happens in this. And you all know ASP activated sludge process. There is no attachment of the bacteria. So ASP and SBR are suspended growth processes. Next question. Select the correct statements regarding disinfection and its methods. Okay. Ozone forms residuals in disinfection processes. The disinfection efficiency of chlorine decreases by increasing the time of contact. Turbidity affects UV removal efficiency. Ozone requires relatively shorter contact time than chlorination. So which of them is correct?
D.
B or D?
D is Delhi, sir.
D Delhi. So yes, definitely ozone will require shorter contact time because it is more efficient. Any other correct answer? Yeah. So C is also correct because if turbidity is there, okay, so this turbidity or suspended solids will act as a shield for these microbes. Okay, they will protect these microbes from getting disinfected. So definitely turbidity will affect the UV removal efficiency. So it will act as a shielding effect. So that's why option C and D both are correct. Whereas ozone will not form any residuals in the disinfection processes, and the disinfection efficiency of chlorine will increase by increasing the time of contact. Okay. So as the time of contact increases, it will increase the efficiency. Right. Okay, again a small numerical like what we have solved previously. So please quickly solve it. So once I have already shown you the answer, so please quickly solve it. A disinfectant solution is used to inactivate a certain microorganism with the initial concentration of 2.5 into 10 to the power 7 CFU per ml. The inactivation rate constant K is determined to be 0.03 hours. How long does it take to reduce the organism's concentration to zero point 0.5 into 10 to the power 5 CFU per ml? So this time they have not asked the volume, but the time period. So quickly tell me the answer. So tell me the answer in hours only. Okay, so here K is given in 0.03 hour per hour. So tell me the time in hours. Anyone with the answer? I hope you know the formula. No one? The correct answer is 207.15 hours. So simply again that same formula which is known as the Chick's law equation. So n is equal to n naught into k to the power minus kt. So everything is given. You have to just find out t. So it will be 207.15 hours. Is it clear? So n here represent the number of organisms after time t. N naught is the initial number of organisms and k is the rate constant. Okay. Right. Moving forward. Now a different type of numerical. The pH of a solution after adding an acid, okay, Ha, with a pKa value of 3.6 is 4.8. So the pH is 4.8. If the concentration of the deprotonated form A minus is 10 to the power minus 3.2 molar, then the concentration of acid Ha at equilibrium is how much? So you have to find the answer in 10 to the power minus 5. Okay, in terms of so just the starting coefficient we want. Just go through. So pH is given and concentration of A minus ions is also given. I hope you have noted down the problem. I will show you how to solve it. So this is question number 18. So suppose there is one acid. Okay, we are writing it as Ha. So it is dissociating into H plus A minus. Right, this is how it will dissociate. Now this A minus concentration is given as 10 to the power minus 3.2 molar. The pH of the system is given as 4.8 and the pKa value, like the dissociation constant, is given as 8.36. And you have to find out what is the concentration of Ha. What is the concentration of Ha? Okay, so this can be easily solved from Henderson Hasselbalch equation. This is known as Henderson Hasselbalch equation, and it is given as pH is equal to pK plus log of the concentration of A minus divided by the concentration of Ha. Okay, very simple formula. So directly you have to put it. So pH is 4.8, pK is 3.86 plus log of A minus concentration is 10 to the power minus 3.2 divided by Ha concentration. So if you solve this, you will get as Ha as 7.244 into 10 to the power minus 5 molar. So my answer will be equal to 7.244 because in terms of 10 to the power minus 5 molar we have to find out. The correct answer will be 7.244. Is it clear to all of you? So this is known as Henderson-Hasselbalch equation. Just note it down. Okay, so now since we have solved this problem, I will give a similar problem for you to solve. Okay, I will give a similar problem. Yeah, please solve this. Here we don't even need the Henderson-Hasselbalch equation. We can directly solve it if we can apply the concept. So here it says that find out the pH of the system when HOCl dissociates at equilibrium. So it is saying at equilibrium, considering HOCl as 9.53 into 10 to the power minus 6 and pK as 7.54. So here you can, since uh, here you have to find the pH, and if you see OCl minus concentration is not given, right? In the question, it is not given. So what you can do is you can assume we have to assume that H plus concentration is equal to OCl minus concentration. Okay, so this small change you have to do. So at equilibrium, we will assume that H plus concentration will be equal to OCl minus concentration and then solve it. Okay, so I will just show you a similar kind of problem, just little different approach. Okay, so here what is happening is at equilibrium 6.55. Yeah, it is close. It is close, but not exactly correct. But yeah, it is close. So at equilibrium, we have HOCl, which can be in the form of OCl minus plus H plus. Okay, now we all know that dissociation constant or activity constant, whatever, we can say it as H plus into OCl minus. So product, so multiplying the concentration of the product divided by the concentration of the reactant. Okay, so this is the now this pK value is given. pK value is given as 7.54. So from this we can find out K. K will be, so if we calculate, it will be 2.844 into 10 to the power minus 8. So pK is nothing but minus log of K. So like that we can calculate. So it will be 2.844 and HOCl concentration is given 9.53 into 10 to the power 6. And also we have to assume at equilibrium that H plus is equal to OCl minus equation concentration. So we will put all these things in this equation, all these three statements into this equation. So ultimately you will get H plus as 5.24 into 10 to the power minus 7. So pH will be minus log of H plus minus log of 5.24 into 10 to the power minus 7. So it will turn out to be 6.28. So that's how you have to solve the problem. Okay. Okay, I have one more similar problem because these kind of questions are asked generally. So I will show one more problem and we will solve it. So here it says that find out the concentration of OCl minus at neutral pH. Okay, at neutral pH, considering HOCl as 9.53 into 10 to the power minus 6 moles per liter and pK as 7.54. So again, pK 7.54 is given. We have to find out the concentration of HOCl minus, and here the pH is mentioned. So that means we don't have to assume that OCl minus is equal to H plus. Okay. So all other thing parameters are given. Only OCl minus concentration is not given. So similarly, again, I will just quickly solve it. So here if you see in question number 28, here it is not given at equilibrium. So just here K, okay. So H plus will be neutral pH means pH is 7. So concentration will be 10 to the power minus 7. Okay. K we know 2.887 into 10 to the power minus 8 because pKu 7.54 is given. So that Ka value will be 2.88 into 10 to the power minus 8. Then H plus we know 10 to the power minus 7. Then OCl minus we don't know, and HOCl we know, that is 9.53 into 10 to the power minus 6. So OCl minus is pending, so that will be equal to 2.75 into 10 to the power minus 9 moles per liter. So this is the answer. Okay, just you have to play with these many parameters. That's all. So same thing is given here. Okay, now we will solve a little bigger problem. So this is regarding the phosphorus removal through biological system. So it says that estimate the amount of phosphorus removed. Also calculate the phosphorus in the filtrate and total phosphorus in treated effluent. So COD, BCOD is, what is BCOD?
BOD only, sir.
Yeah, it is
Biological
nothing but
CO2.
BOD. So that is biological COD. And what is BSCOD? So out of the biological COD, how much is biologically soluble COD? So we have soluble and particulate COD. So BSCOD is 50 milligram per liter. So out of the 200 milligram per liter of BCOD, 50 milligram per liter is soluble. Then phosphorus concentration is initially 6 milligram per liter. Now YT, yield constant, decay constant, okay, theta C, P content of phosphorus accumulating bacteria, P content of other type of bacteria, effluent VSS, everything is given in the question. Okay, so you have to find out how much amount of phosphorus will be removed. So here, what we have to take care is there are two kinds of bacteria. One is the phosphorus accumulating bacteria, and one is the other kind of enterotrophs. Okay, so always remember the phosphorus accumulating bacteria will only consume the easily available soluble CO2. Okay, whatever biologically soluble CO2 is there, so that CO2 they will easily consume. Other CO2 will be consumed by the other BCOD will be consumed by the enterotrophs. So only this has to be taken into consideration. KD and theta C is just given to calculate the observed yield. I hope you have noted down the problem or taken a screenshot. I will solve it. You just see. So question number 29. So first we will find out the observed yield. Okay, it is nothing but total yield divided by 1 plus KD theta C. So if you put all the values of YT, KD and theta C, it is given. So you will get it as 0.28. Observed. Now, phosphorus accumulating bacteria produced. So what is the amount of phosphorus accumulating bacteria that will be produced? So this will be equal to YOB, Y observed, into the soluble food consumed. Right, soluble. So Y observed is nothing but 0.28 and soluble food or the BSCOD. So it will be 0.28 into 50. That is nothing but 40 milligram. That is 40 milligram. Now we will calculate how much is my heterotrophs produced. So again it will be Y obvious into the remaining food. Okay. So it will be 0.28. And what is my remaining food? Remaining food will be BCOD minus BSCOD. So it will be 200 minus 50. That is equal to 42 milligram. Okay, these many heterotrophs are produced. Now, based on this production of bacteria, the phosphorus will be obtained. Now, in the question it is given that for every gram of PAD that is produced, it will obtain 0.3 grams of phosphorus. Okay, it will obtain 0.3 grams for every gram of PAD produced. So, what will be my P accumulated by PAD? That will be nothing but 0.3 into the 40. So 4.2 milligram per liter. Okay, 4.2 milligram per liter. And what is my P accumulated by the heterodrop? P accumulated by heterodrops, HT I am just writing. So that will be very less because this heterodrop will not accumulate much of the phosphorus. They will only take the phosphorus for their bacterial activity. So that is 0.02. It is given in the question. Into the food or the mass produced, that is 42. So it will be 0.84. Okay. So total phosphorus that is accumulated will be 4.2 plus 0.84. That is nothing but 5.04. So what will be my P in effluent? So whatever is there initially it was 6. So out of that 0.54 it is getting consumed. So only 0.96 milligram per liter. Enough. So my effluent will have 0.96 milligram per liter. So now if we see the biomass average into both kind of biomass, phosphorus accumulating bacteria and the heterotonic bacteria. So average how much is there? So if I want to find out average T in the biomass, so that is nothing but 0.3 in 40 plus 0.02 in 42 divided by 14 plus 40. So this is 0.09 milligram per. Okay, this much is there. And now effluent VSS is given in the question. Effluent VSS given in the question is 8 milligram per liter. Okay, so what will be my P, the VSS, effluent VSS? So average whatever we got into the effluent. Okay, this won't have any this 0.09 cancel. So we will get the P in VSS 0.70 milligram per liter. So my total P in effluent will be 0.72 plus the 0.96 that was remaining earlier. So it is 1.67. This looks a bit lengthy, but step by step, if you see, it is nothing, just a very simple calculation. All the parameters you should. So that's all. By one, first how much PAB is produced, then how much heterotrophs is produced, then what is the phosphorus accumulating in the PAB, then what is the phosphorus accumulated in the heterotrophs, then total phosphorus accumulated, then what will be in my effluent. Okay, then we will find out what is the average phosphorus in my biomass, and from that we will find out the phosphorus in my volatile suspended solids, and then we will add both the effluent and the volatile suspended solids phosphorus. So finally 1.68 will be there. Okay, so that's how it is done. Now the next question is, okay, this question uh, I I have given in the previous class. Okay, I told you that I would discuss it today. So we have an activated sludge plant which is treating municipal wastewater. Okay, the kinetic constants Y, Kd, Ka, and Ks all are given to you, and the influent BOD is 400 milligram per liter with an aeration period of 6 hours and a solid retention time of 5 days. Okay, so you have to calculate the effluent soluble BOD, removal efficiency, concentration of microorganisms, MLSS, specific BOD utilization rate, and F-diode ratio. Okay, so I know you all have this question already, so I will just give you the solution for this so that you can cross-check your answers, which we have solved yesterday. So question number 30. So I will just give the solution quickly. So first part, what is my effluent BOD? So effluent BOD is given by S. That is nothing but Ks 1 plus Kd theta C by theta C Yk minus Kd minus 1. So this is the general equation. We discussed many questions based on this last time. So it will be 50 into 1 plus 0.05 into 5 divided by 55 0.5 into 5 minus 0.05 minus 1. Okay, so I will get 5.6 milligram per liter of beer. So this is my effluent concentration. Now next is the efficiency. So efficiency is given as S naught minus S by S naught into 100. So this will be equal to initial period was 200, final was 5.6 by 200 into 100. So we will get it as 97.2%. So this is my efficiency. Now next is the biomass in aeration. So that is given by X. So the formula is 5 theta C into S naught minus S by 1 plus Kd theta C into theta. Theta is nothing but the HRT. So it will be 0.5 into 5. This is 5 days. So I will convert it to hours, 24 hours per day. Then 200 minus 5.6 by 1 plus 0.05 into 5 into 6 hours. So you will get the answer is 1.5 milligram VSS. Then MLSS they are asking, so this is nothing but ML VSS. So we have next question they are asking MLSS. So MLSS is nothing but ML VSS divided by the ratio of MLSS by VSS. So this is 1.5 by 0.7. It is given in the question. So it will be 1994, or we can say approximately 1,000. Last, okay, second last is specific substrate utilization rate. So this is nothing but given by Q, which is S naught minus S by theta X. So S naught is 200 minus 5.6 divided by 6 hours into 1,555x. Hour into days, if we convert, it will be 24 hours per day. So the final answer will be 0.5 milligram POD5 per milligram of VSS. So this is the specific substrate utilization rate. And the last one is F by M ratio. So this is nothing but S naught by theta X. Okay, so it will be 200 by 6 hours into 1,555, converting days, 24 hours per day. So the final answer will be 0.15 milligram POD5 per milligram VSS. So I have not discussed this in detail today, but we discussed all these equations in the previous class. So I'm just giving you the solution for your reference so that you can cross check with your answers. Okay. So these are all the points. Okay, and the last question, which I discussed in the last class also. Again, I will just give you the solution for you now for you to check and match with the answer. So it says that in a biological treatment facility, it was found that 1 gram of microalbumin will decompose glucose at a maximum rate of 1.5 milligram per day. Okay, when the concentration of glucose was high. It was also found that in the reactor at glucose concentration of 15 milligram per liter, the reaction rate is half of the maximum. So K's value is given, half saturation constant. Now you have to calculate the rate of glucose decomposition, that is Ds by dt, when glucose remaining is 5 milligram per liter, that is nothing but the S, and microbial concentration is 2 gram per liter, that is nothing but the X. So all these parameters are given. So just you have to put it in the equation. So question number 31. So specific utilization rate, we give Q. It is nothing but ds by dt into 1 by x. This is the specific utilization rate, and it is equal to k into s by ks plus s. Okay. So if it take, we want to find out ds by dt. So my ds by dt will be equal to k into s into x by ks plus s. So here k is nothing but 1.5 milligram of glucose per milligram of VSS day. So this is K, because in one day 1.5 milligram is consumed by 1 gram of bacteria, by 1 milligram of bacteria. Ks we discussed 15 milligram per liter. S final is 5 milligram per liter, and X is nothing but 2 gram per liter, or we can write it as 2000 milligram. So my ds by dt, and since this substrate is being utilized, so I will just put a minus sign. So minus ds by dt. So minus ds by dt will be equal to 1.5 into 5 2000 divided by 15 plus. So 750 milligram of glucose per unit day. So, so my ds by dt finally I can plus minus 0.75 kg glucose per. So I just change the unit, and this negative sign is just because the substrate is getting utilized, so it is getting, it is decreasing in the system. So minus sign. Okay, any doubt in this question? Because extensively we have discussed about the solution, like about the concept in the last class. So I'm just giving out the solution. Okay, I hope it is clear to all of you. Okay. So that's all for today from my side. Okay, we'll meet again next week, that is 11th March, same on Tuesday from 7 to 9 p.m. And this is my contact ID. You can reach out to me in case of any difficulty or any queries on the email ID of saha19akash@gmail.com. Okay, I will reply to. Any other clarifications that you need to make? Or else that's all from my side. You can leave the session. Thank you.
Thank you, sir.
Well, if you don't have any doubts, you can leave the session.